Students, we were discussing the seer circuit. Okay, the basic circuits concepts we have discussed in your theory classes, but here I will go in details about the seer circuit. Okay, I will just go in short whatever I have done till here. Okay, so this is your basic circuit. The alternating voltage is being applied here, and for this you can see the direction of the current. The arrow's direction will tell you the direction in which it is flowing. Here you are having the capacitor and R, C and R. Okay, and yes, so you have taken the value of this alternating voltage that is being applied to the circuit. I'm just going in very short whatever I have done till here. Okay, the alternating voltage is value. I've written equation 1. Okay, after that, since you're having one capacitor, so obviously there should be one drop, isn't it, across this capacitor. So after this drop, whatever the net voltage that you will get in the circuit, understood, that is the net or effective voltage that it is being applied in the circuit. After there is a fall of this capacitor voltage, or yes, capacitor voltage is your these, that is your VE or net effective voltage. All right, so after this, students, I have just applied this effective voltage into this Ohm's law. Okay, I have taken the value of q is your charge. All right, so I've assumed this q's equation by this. I've taken, after this I have found out the value of this I by differentiating q with respect to t. All right, and I've just arranged the equations. If you just go in details, then you can able to see. Just I will explain this turning point, students. These two tips I've just arranged it mathematically. Okay, but I'm coming to this equation number 3. I'll just explain in very short. What I did, students, you have taken some common terms outside the bracket, but I have taken another term, that is z. Okay, and since z was not there in either of the terms inside the bracket, so I've divided each of the terms by z, which is your z, students. If you just go through your previous circuits, you will be able to know that z is the impedance of the circuit. All right, and z's values is this. I've written in the bracket. Okay, so after this, students, I've assumed your constant terms like r by z, and another constant term attached to this sine part is 1 by omega c by z as your cos theta and sine theta. See, I've written in the bracket. Okay, yes. So, and one more thing, students, in these two equations I have written detours. These are the symbols of detours. Don't think it as numeric 11. That means you will write here v naught sine omega t in both the steps, okay, in your exam. All right, so let's move ahead. So I've reached till here. Okay, okay, so yes, I have expressed this particular equation in terms of cos a minus b, if you just go through your formulas in maths. Okay, so next let's see how I can write it. Equals to omega q naught z sine okay. So what I did, students, in the previous equation I've written in terms of cos, okay, but now I've written it in terms of sine. So yes, so sine theta plus 90 degree will give you cos theta, isn't it? So just I did, and here also determines v naught sine omega t. Don't think it as numeric 11. Repeatedly telling all this. Okay. So now, students, what will I do? Comparing both sides. All right. Okay, so what I did, students, since you had sine in both the sides, so I've just compared the terms. Okay, compare the constant terms. So in the LHS part I had omega q q naught z, and in the RHS part I had the constant term v naught. Okay, so I've just equated the two constant terms, so I'm getting q naught as your v naught by omega z. Okay, so let's see how I can write it in another way. Okay, students, this also, see what I did, we are doing the comparison here in these two steps. Okay, first step I have discussed. Now students, what I did in the LHS part, you had uh, omega t. First of all, you both had in the two sides of the equations, but alpha minus theta plus 90 degree equals to 0 degree I can write, because you had nothing here in terms of this alpha. So when I am doing the comparison in both of the sides, so I can write it in this way: alpha minus theta, see this part, see after this omega t plus this, the term that I have written, so I will follow this term, I have followed this term, alpha minus theta, see alpha minus theta plus 90 degree equals to 0, because you had nothing here in this case of sine omega t. Okay, I'm just writing here, it will be easier for you. V naught sine omega t. Okay, yes. So yes, after equating this, I'm getting the value of alpha as theta minus 90 degree. Okay, now yes, now what we can write, I equals to what I did, students. Yes, I've written the value of I, okay, as omega q naught cos omega t plus alpha. All right. Yes. This value of I, where did you get in this particular equation? See, on this top equation of I, you got this. So I've just written it here again. Okay. So now I've got the value of this Q and alpha. So let's write those values. Omega V naught by omega Z